reflection over an x-axis. So that would mean if it's moving over an x-axis, so we're talking about something that is above the x-axis, and then it would be reflected below the x-axis. Then you can see that means the y values are changing. The x's are still the same, but the y values have changed. And that is because we have the negative on the outside of the function. So if there's a negative in front, that means the y values have changed. It's reflecting over the x. Now, if we're talking about a y-axis reflection, then we're talking about a starting graph, say like that, and then if it reflects over the y, it would look like that. So that means it's flipping left and right, and the x values are changing. And that would mean there's a negative inside on the x itself, so inside the parentheses. So, for example, negative x squared, we know that's a reflection over x. And if you want to look at the table, you can do the table or you can do the parent graph method. Let's look at both. So let's take our x squared table. And we plugged in -2, -1, 0, 1, 2. And we got, for the original graph, 4, 1, 0, 1, 4. And then all you would do is, so for reflection over x, you're changing all the y values to negative. So negative, 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 negative. Okay, so a graph of this, let's start with the parent graph. So we know x squared is 0, 0, -1, 1, -2, 4, and then 1, 1, and 2, 4. And then the reflection would be 0, 0 stays, but instead of going up 1, you go down 1 on those 2 points. Instead of going up 4, you're going down 4 on those other 2 points. So this graph, the red graph is a graph of the reflection. All right, so on this one we see the negative is on the x, so that means it's reflecting over y, which means the x values are changing. Let's start with the table in case you want to use tables. For cubed root, we plugged in -8, -1, 0, 1, and 8. And then we got -2, -1, 0, 1, and 2. And then since we're putting a negative on the x here, you just change all these to positive, or put a negative on everything. So negative, 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 negative. So these double negatives will change to positive. And you can plot those points. Or if you want to do the graphing method with a parent graph, then you can plot your cubed root, which is 0, 0, 1, 1, and then 8, 2. And we've got, -1, -1, and then -8, -2. That is your parent graph. And then you reflect over the y-axis. So we've got 0, 0, and then this point is going to reflect over here to that. This point is going to reflect over here. This point is going to reflect here, and then this point is going to reflect there. You're just doing the opposite over the y-axis. Or, yeah. Okay, so those are what your graphs would look like for those. Vertical stretch and compression. So, if you have a number in front, and it's larger than 1, for example, like 3, you're going to stretch it by 3. I guess we should say vertical. Vertical stretch by 3. If that number is a fraction, then you're going to compress, or it's going to get smaller vertically. Okay, let's do this with, let's do it with both a table and a graph. Okay, absolute values. We plugged in -2, -1, 0, 1, 2, and we got out 2, 1, 0, 1, 2. And this 3 in front is just telling you to take these times 3. So 6, 3, 0, 3, 6. And you can plot those points. Or you can start with your parent graph, which is really we're going to do basically the same thing. This would be -2, 2. -1 is 1, 0, 0, 1 is 1, 2 is 2. You would take that and you would multiply all those y values by 3. So instead of being at 2, instead of being at 2, it'll be at 6. 1, 2, 3, 4, 5, 6. This point, instead of being at 1, will be at 3. 0 times 3 is 0. This point will be at 3, and then this point will be at 6. The cool thing with doing the parent graph method is you can see both graphs compared, and you can see what happened and how this graph got stretched. It got like pulled higher. It goes higher faster in terms of y values. Okay, this one, you can do the same table method where you just multiply the y's by 1/2. Or let's just do the parent graph version. So for x cubed is the function. So x cubed has 0, 0, 1, 1, 2, 8. -1, -1, and then -2, -8. That's a graph of the original, or the parent, and now we're going to take half of all those. Half of 0 is 0. Half of 1, you're just going to go to 1/2. Half of 8 is 4, so you can go up 4. Half of -1 is -1/2. And then half of -8 is -4. And this one is kind of hard to see the change, but hopefully you can see that it's kind of smushed towards the x-axis. The blue curve has been smushed towards the x-axis. Just in the stretch, it's like being pulled away from the x-axis. And that is the end of your notes on library of functions.